Hello everyone, I am Gokula Vashni, Assistant Professor in the Department of Food Technology. So welcome to today's session on basic principles of sensor operations. So first of all, sensors are the invisible hand behind many of our smart technologies, from smart homes to smart factories. They are helping us bridge the physical world with the digital one. In this session, we will explore what sensors are and how they work and the key types and why they are used. So first of all, what is sensor? Let us begin with the basic. So what exactly is sensor? A sensor is a device that detects the physical input from the environment such as heat, light, motion or pressure and converts it into a measurable electrical signals. So think of it as a digital sensors of a machine. Just like our eyes sees and our ear hears, sensors enable machines to perceive their surroundings. So these are the basic principles of sensors. So first of all, the transduction principle. So at the heart of every sensor is the transduction principle. This is the process of converting one form of energy into another. So sensors can be classified as active or passive. So first of all, active sensors require the external power to operate, that is like thermistors, and passive sensors generate their own signals like thermocouples. So for example, a thermistor changes its resistance with temperature. This is a direct application of converting the thermal energy into the electrical resistance. So let us see about the key performance of the matrices. So first of all, how do we judge the performance of a sensor? There are four key parameters. So first one is the accuracy. So accuracy is nothing but how close the reading is to the actual value. Next is the precision. In this, the repeatability of the measurement is called as precision. Next is the resolution. The smallest change in the detection is called as resolution, and last one is the sensitivity. So in this, how much the output changes with the input will be calculated. So for example, in a temperature sensor, high sensitivity means a large voltage change of a small temperature variation. So next one is the common sensor types. So first one, there are many types of sensors. Let us look at into a few common things. So first one is the temperature sensor. In this, there is a thermistors, RTDs and thermocouples. Next is the pressure sensors. These converts the force into electrical signals. And next is the proximity sensor. In this, the presence of the objects without the contact is detected, like those in of the automatic doors. So each type has the unique property suitable for the specific environment. And coming to the next, the common types of sensors are light sensors, motion sensor, gas chemical sensors, biometric sensors. So light sensors are used by the photodiodes or phototransistors. Motion sensors include accelerometers and gyroscopes. They are used in phones and drones. Next is a gas or chemical sensor. It detects the harmful gas like carbon monoxide and sensors in homes. And biometric sensor used variables to measure the heart rates and SpO2 levels in our body. So these sensors are vital to the health monitoring and consumers electronics. Next is the sensors interface and the signal conditioning. So once the sensor gathers the data, how does it communicate with the system? In this, the analog output sensors produce the continuous signals which requires the analog to digital converters like ADCs. Next, digital output sensors communicate directly via protocol like I2C, SPI or UART. So the signals often goes through the conditioning, which includes amplification, filtering and linearization to improve the accuracy. So next one is the application. So here the sensors are used in nearly every modern industry. So first of all is the automation. Over 100 sensors in a car, single car, from an engine control to the LDAR. So in the healthcare, from fitness blade to glucose monitors and MRI scans. And in industrial automation, they used robotics and predictive maintenance. And IoT and smart home uses sensors for environment, motion, energy control, etc. So they form the backbone of the industry 4.0. And next one is the challenges and future trends. Here, despite their power, sensors faces challenges. So power efficiency, especially for IoT, and miniaturization to fit the smaller device, and environmental durability in harsh conditions. So these are the main things to be focused. And on the future, exciting trends will be included like edge AI, engineer energy harvesting, flexible sensors. So AI running will be directly on the sensors, and also it will be self-powered sensors, and wearables and biodegradable devices will also be used. So it's the time for conclusion, and to conclude, sensors are the foundational elements that make machines intelligent. By transforming the physical data into the digital signals, they support innovations in every field. Understanding sensors principle is crucial for engineers working in food tech, healthcare, automotive and beyond. So thank you for joining this session. We shall continue this in our next class.